slope-intercept form, which is a really fancy way of saying the way we write the equation of a linear relation. And we want to write it in a way that is standardized or consistent so people can identify. Okay. And that form is y equals mx plus b, where m is the slope of the line and b is the y-intercept of the line. Hence why it's called slope-intercept form. In slope-intercept form, it is easy to identify the slope of the line and the y-intercept of the line because the slope is always the thing in front of the x and the y-intercept is always the thing not in front of the x. And we can identify them straight from the equation. So, for example, what are the slope and y-intercept of the relation y equals negative 3x plus 2? Well, here, the thing in front of the x is the slope, and the thing that's not in front of the x is the y-intercept. So the slope is negative 3, and I'm going to write it as negative 3 over 1 for myself, rise over run. And the y-intercept is positive 2. Positives and negatives make a big difference here. The slope and y-intercept of the relation y equals 5 minus 1 over 2x. Now this is a little bit backwards because the slope is always the thing in front of the x, and the y-intercept is the thing that is not in front of the x. So these are written in backwards order. The slope is negative 1 over 2, and the y-intercept is positive 5. Now, by having the slope and y-intercept easy to identify or to read, we can graph a relation without first having to make a table of values. So if, for example, I want to graph y equals 2x minus 4, I'm going to start by identifying the slope and y-intercept from the equation. So in this case, the slope is the thing in front of the x, it's a 2, and the y-intercept is the other piece, and it is a negative 4. That negative sticks with it. So once I have those pieces, I'm going to follow the graphing steps when you were given a point and a slope that we practiced before. I'm going to put a dot on the y-intercept at negative 4, and I'm going to use that slope up 2 over 1 to get my next dot. And repeat from that dot up 2 over 1, get my next dot, and I'm going to erase all my little bouncing lines here because I don't need them. Once I have 3 dots, I'm going to grab my ruler and I'm going to connect these dots to make sure they are all in the straight line. That's great. And I've graphed it without having to make a table of values at all. Let's try another. Graph y equals 1 over 3x minus 4, or plus 4. So the slope in this case is 1 over 3, is the number in front of the x, and the y-intercept is positive 4. So once again, I'm going to put a dot at positive 4 on the y-axis at 0, 4. I'm going to use that slope, rise of 1, run of 3, to get to my next dot. Rise of 1, run of 3, get my next dot. And erase all my little bouncy lines. Connect the dots with my ruler. And there we go. I've got a graph. Let's try one more tricky one. Graph y equals 2. Now here, I need to identify my slope and my y-intercept, but there's no x, which means I don't have a slope. What it actually means is the slope is 0, because 0 times x is 0, so we don't bother writing it in. So the slope is 0, and the y-intercept is the thing that is not in front of the x. It's the number 2. So I'm going to put a dot on the y-axis at 2, and I'm going to have a slope of 0, rise of 0, run of 1, and connect these dots, and I should get a flat horizontal line where all the y parts are 2.